I want to say, maybe this is going to be disappointing to you, but I want to say maybe not very much. Just like, what does the linguist of French bring to French speakers? Like, not much. They don't need to go learn the grammar to be really good. You could be a great poet or a great novelist in French and like have total mastery of the language, but have no idea what the linguistic theory is. And it's not clear that learning the correct grammar of French in the sense of a linguist is going to like help you be a better writer. And so I think the same thing, like, it depends what you mean. Like, what philosophy of mathematics brings to, if the table is like all of academia and like the body of human knowledge, then philosophy of mathematics is bringing a lot to the table, namely knowledge of reality and the nature of mathematics. But if the table is just mathematics, it's not bringing a lot because it's not telling us the answers to mathematical questions. Now, sometimes I think it can bring this much, and this is maybe going to be a little bit more detailed than you want, but in mathematics, there are open questions, just like there are in science. So, for example, in set theory, there's a question that's open called the continuum hypothesis, which is basically, like, to make it very simple, in set theory, we know that there are many sizes of infinity. It's a sort of surprising result. Intuitively, it seems like maybe there's just one. Once you get to infinity, you can't get bigger. But George Cantor proved that there are many sizes of infinity. In fact, infinitely many sizes of infinity. There's more real numbers than natural numbers. And the natural numbers is the smallest infinity. And the real numbers is bigger. And the continuum hypothesis says that the real numbers is the second biggest, the second smallest, it's the next smallest kind of infinity. And the question is there another kind of infinity between the natural numbers and the real numbers? And it's an open question. And not just is it an open question, it's unprovable in current set theory. So in order to settle it, we need to find a new axiom. A lot of mathematicians got into this idea that because it's not provable in current set theory, there's no right answer to be had to the question. And other mathematicians thought, no, there is a right answer because realism is true. So if you thought math is about abstract objects, like Kurt Gödel thought, then you would think there's a right answer. There are real objects out there. We have to find the answer. And if you thought, no, there's not really any abstract objects. These are just theories we've created. They're just formal systems. So there's no right answer. But both of those people, in saying that, and this can dictate how mathematical research goes, whether people are trying to settle the question. But both of those groups are smuggling in philosophy, right? They're doing philosophy of mathematics when they come to these conclusions. But just like I'm not a mathematician, they're not philosophers, and mathematicians might get it wrong. And in this case, I think they did get it wrong. And the right thing to think is that the philosophical question of whether there really are abstract objects is independent of the question of whether there's a right answer to the question. And whether there's a right answer to the question depends on whether we've got a precise notion of set in our head and whether we've zeroed in on one structure. And so that's one way in which philosophy of mathematics can help mathematics, is by preventing them from making mistakes in the philosophy of mathematics that lead them down a wrong path in the research of mathematics.